So yesterday we have seen an introduction class regarding what is software engineering, what are all the objectives of this course, and what are the outcomes you people will be learning after having this course. So we had a brief introduction yesterday. This is what we just a minute. So right, this is what we saw yesterday. We have gone through the objectives. We have seen the outcomes, what you people will be learning finally by the end of the semester. And we saw what is the purpose of learning the software engineering subject, right? And finally, we started with the introduction part wherein we saw the definition for software. So our subject is software
Madam,
engineering.
excuse me.
So,
Remove the user P3M6TD. Host have permissions to remove this kind of students. So if you want to join, join with the register number, or else we can remove those kind of people. Okay, only the guy.
so you are having a
It's my
renaming.
request.
Students, you will be having the renaming option. Please check it. You can rename your device with your register number. There is no need for you to re-log in again. So right, yesterday's class we started with the definition for software. We told that the software definition has three components. First one is the instruction, the data structures, and the documentation. So software, I can say these are the set of instructions. All these instructions are used to perform a particular or used to reach a particular goal. So this is what we saw yesterday. And data structures, by using these data structures you can manipulate your data. And finally the documentation part, which helps us to know what has done, what are the operations that can be done within the program. Okay, right? We saw the definition for software, and next we saw the definition for engineering. So our aim is to develop the software. For developing the software, we need to follow some scientific principles, methods, and procedures. This is what we call as engineering. So it is not for developing any software product. The same thing apps for developing any hardware component also. Whatever component you develop, whether it is a hardware or a software, you need to follow some principles, methods. So this is what we call as engineering. And combining both these two, we came for the definition for software engineering. And combining these two, we saw the definition for software engineering. So what we told is software engineer, we asked you to follow this IEEE definition, which is a standard definition. So what this IEEE definition tells us is our aim is to develop a software. See here, our aim is to develop a software. For developing that software, you need to perform some systematic approach, that is nothing but some structured approach, and some disciplined approach. Discipline in the sense some repeatable or some regular, repeatable approach, and a quantifiable approach. Quantifiable in the sense you'll be able to measure whether the finally developed product is a quality product or not. So all these measures all these approaches need to be followed for while developing or performing operations and maintaining your software. So this is what we saw IEEE definition yesterday. And coming later, we saw the characteristics of software. In this characteristics of software, we try to differentiate between the software and hardware. What we saw is the first one is we told that software is software is just a second. Right, software is engineered and it is not manufactured like a hardware. So this is what we saw in the first characteristics. So what we try to elaborate here is, while developing a software or a hardware, in both the cases you need to have a proper design. But even though you have a proper design, while developing a hardware component will be facing some failure issues initially, which takes most of the time to rectify. When we come to software, while developing the software also we'll be facing some issues. The issues are in the sense of errors. We'll be facing some errors in the beginning, but it takes less times to rectify those errors that occur in software when compared to the hardware. That is what we try to elaborate here. We try to differentiate between hardware and software. In both the cases, we need manpower to develop a hardware component. We need some manpower, and same for the software also. But comparing in both these two cases, we need more number of manpower in hardware development when compared to software. Okay. Finally, in both the cases, the end product will be a quality product. That is what we try to differentiate here yesterday. And second thing, what we try to told is software doesn't wear out when compared to a hardware. So what we try to say here is, even though you use your software for a number of years, for a couple of years, software doesn't wear out or tear out, or in the sense it does not spoil. Once you use the same software for a number of years, it does not spoil at all. Whereas coming to a hardware, if you use a hardware for a couple of years, definitely the components will be deteriorating. Okay, na? So that is what we try to explain in these graphs. So this first graph, we try to explain about the hardware. See, if you plot this graph, if you see, observe this graph, in the x-axis we are having a time, and in the y-axis we are having the failure rate. So what we try to tell here is, initially while developing any hardware component, that is, for suppose you are developing a car, you are developing a fan, any hardware, while you are developing that, initially we'll be having a more failure rates. That is what the curve is high here. The failure rate is high. And once you start developing and once you start rectifying all the issues in that component, until some stage, when you reach to some stage, your component will be almost ready. It will be released into market. See, I'm showing an arrow here. Once the component is released into market, it keeps on working normally. So I'm having an idle curve here. Can you see the mouse? See. Right. I'm having an ideal curve here. This is what we are showing here. And next, after some period of time, again the hardware component deteriorates. So this is what we are showing here. Again, the failure rate increases for hardware. Whereas coming to the software, see here, the failure rate initially will be high for software as it is for hardware also. As it is for hardware, failure rate is high. In the same way for software also, while developing the software, we'll be facing many of the issues. So the failure will be initially high. But once we try to rectify all those and release into the market, see here, as the time goes on, the software keeps on working normally in the same case. So we have shown an idealized curve here. It means that the software keeps on working in the same way for as the time moves on, as the time goes on for a number of years. So this is the curve. For hardware, we'll be having a bathtub curve. This curve is resembling like a tub. Whereas for software, we are having an idealized curve. This is what we showed here. And the curve above is also showing the hardware, the software failure rate. But if you observe this curve that is shown above, initially the failure rate is high. But see this point, I have marked a point here. I'm naming it as change. Change in the sense, we don't use the same software for a couple of years. For suppose while I was studying, I'm having Windows 2003 or 5, something like that. And now you're in most advanced versions. Not For suppose consider Word document. Word document which I was using while I was studying was 2003 document, where I don't have many features in that document. Whereas coming now, you are having most advanced documents like 2007 versions. The difference between both these versions will be, you'll be definitely having some advanced features added in the latest versions of documents, right? You'll be having different options, like for suppose while I was studying, I don't have any option of capitalizing all the words at the same time. I need to turn on the caps lock and I need to type the capital letters if at all I want the capital letters. But now in your Word document, even though you write in a smaller case, you are having a single option by which you can make all the words in a capital letters, right? So these are all the features that are added in the next versions of the Word document. So that is what we are saying here as change. So for suppose if you take this as a Word document, initially the document has less features. This is a small change which the Microsoft people have made. Maybe any change in a painting or any change in a, as I told you, in uppercase generation or anything, any sort of change. While making that changes in the software, definitely they'll have some failure rate. So I have shown here an increased failure rate again. If I'm trying to make any modifications in the software, definitely the failure rate will be increased again. Again, we'll try to rectify that failure and bring it to a normal stage. Again, if I, again in the next curve and the next higher curve here, if again if you want to make any change, again the failure rate increases, again it comes down, again failure rate, so on. So all this increasing in the failure rate are showing when we want to make change. If at all we want to make change in the software, then only the failures will be increasing. If you don't want to make any changes in the software, and then the curve keeps on goes on in the same way in an idleness curve. So this is what we tried to explain yesterday. uh, These are the three characteristics we saw yesterday, and the third characteristics we told that the industry is moving towards component-based construction. Component-based construction is nothing but reusable components, which I already clarified yesterday. So reusable components means while developing any software, you don't start all the things from the beginning. You'll try to make the maximum use of the previous components that already exist. Previous modules that already exist, we take all those modules, we take all those components, we only just make required changes in the previous components that are present. So that is what we told it for software. So these are the three characteristics, we already saw it in detail yesterday. And now coming to the next part, software applications, where our software will be, what are the areas, what are the applications where our softwares will be used. Different kinds of softwares will be used. In that, the first one is the system software. Coming to this system softwares, these are the softwares that are designed to provide a platform for another software to run. For example, if you purchase a new laptop, while you bring a new laptop to your house, it is just a hardware piece, a hardware component, I can say that. You can't just directly open the laptop and work on it directly. When you bring a sealed piece of your laptop to your home, you just can't working on the laptop immediately. The first thing you need to do in your laptop is you need to load an operating system. Generally, you will be loading your Windows. The first thing we will be doing is we load our Windows or any kind of OS, either it can be a Linux or Unix, anything. What that operating system is doing is, this operating system is helping you people who are sitting in front of the laptop to interact with your hardware, to interact with your laptop, right? So it is it is acting as an interface between you and the system you have, or desktop you have purchased. So that can be a best example of system software. Now what the system software is doing there is, it is making the system software is providing a platform to run another software programs. Once you load your OS, from then only you can work with your system by loading different softwares, whatever are necessary for you. So without having the basic system software, you can't interact with your hardware device. So this is a system software. And next one is the application software. So application software, we generally call it as apps, which general terminology used as apps. And coming to these are the programs or a group of programs designed for end users. Here the end user is the person who is sitting in front of yours, in front of the system. So the end user will have different needs according to his area of interest. For suppose I am very much interested in painting. I like paintings very much. I load a software which will help me to perform different scenarios of painting purposes. For suppose you people are interested in gaming, you load a gaming software, you or gaming software which will help you to do your task, do design your games or something like that. So yeah, what I mean to say here is application softwares are not necessary for the system to run. I'll have my system working, I'll have my laptop working even though I don't load my application software. I'm just loading the application software only because of my interest. I'm very much interested in painting. So for my interest, area of interest, I'm just loading that software. It's not that if I don't load that painting software, your system does not work. There is no issue like that. But whereas coming to system software, if you don't load the system softwares, you can't interact with your system. So that is the basic difference between system software and application software. For example, coming to engineering, for application software, I gave you an example as CAD. Here, CAD is a software which is used by most of the civil engineers. As you know, any of your civil friends, they'll be having a CAD lab. So what they do, what this software helps is they help them to design plans by using CAD. They will be able to design some plans. So this CAD software is only helpful for civil engineers. It's not that if you don't load this CAD software in your laptop doesn't work. There is no sort of issue. So hope you understood the difference between system software and application software. And next, coming to product line softwares, these are designed for a specific capability for use by many different customers. Product, as the name specifies, a group of softwares that are related to a similar product. For suppose if I'm having a car, I'll be having some set of softwares which will be apted for car, maybe car working, car automation or something like that. So suppose if you take a products of mobiles, from group of mobiles, I'll be having some set of softwares which will help me to interact with the mobiles. So it can be any similar group of products. Either it can be a group of mobiles, a group of cars, a group of operating systems, anything. So all these products are similar. A set of softwares which run in the particular product, you will be calling that as product line softwares. So these product line softwares can range from, can focus on limited users, either limited number of users to, or can address mass customer markets. In the sense, either some small set of people, small set of users can use that software, or a large number of users can use the same software. For example, you are having a word processing here, or spreadsheets, or computer graphics. All these are some general purpose softwares which will be used by most number of users. Your word software is used by a civil engineer, it is used by a computer engineer, it is used by a normal school student also will be using this word processing or spreadsheets. So these are some set of softwares that belong to some group, some product group. And next, coming to the embedded softwares, the software which works on both software and hardware is known as embedded software. You need some set of softwares which work on your hardware at the same time, the software. Example, the best example for this will be day-to-day day-to-day instruments that we are using in our house. For example, it can be a micro oven. Just micro oven is a hardware device, but you will be able to set some time, how much temperature or time within that oven. That is, you are using some software to interact with that hardware. Another example will be the washing machines. Washing machine, basically it is a hardware component. but by using some software, I'm going to interact with that washing machine. So all those kinds of softwares will be called as embedded software. So embedded software is nothing but software by which we can interact with both software and hardware. So right, these are the types of softwares which we'll be using on day-to-day life. And next, coming to another set of softwares are engineering and scientific purpose softwares. Some particular group of softwares which are used for engineering, or some particular group of softwares which are using for scientific people, for research purposes or so on. So I can say that engineering and scientific softwares have been characterized by a number of crunching algorithms. Crunching in the sense, algorithms which involve most of the mathematical calculations. So these set of algorithms have most of the mathematical issues involved in them, which which will be used by most of the engineering people or most of the scientific people. So for examples, the application can range from astronomy to volcanology. People who are studying related to astronomy, regarding the galaxies, regarding the objects that are having in the galaxy, all these things, from all those people can use the software, starting from the galaxy, from the topmost to the volcanology, from to the bottommost. We'll be having different kinds of softwares related to different fields. So all those software relating to particular engineering field or scientific field comes under engineering and scientific software. And next one is artificial intelligence softwares. AI softwares make use of non-numerical algorithms to solve complex problems that are not amenable to computation or straightforward analysis. So what we mean to say is there are some problems which can't be solved easily. There will be some set of complex problems which can't be solved easily by normal humans by writing some sample programs, right? For example, near the toll gates, we'll be having a number of vehicles moving on. For suppose if I want to record all the car numbers or vehicle numbers that are going on in a day, we can't sit there and keep on noting manually all these things. So we need some system which will be able to recognize the car number board and directly record what is the number, what are the numbers of the vehicles that are going on all the day. Why? Because human can't do all the things, can't solve the complex problems by himself. So we need some set of software, some intelligent software here. Artificial intelligence in the means, this software is going to mimic your human brain. It is going to act as if how we humans think. Generally, we humans are having some neurons in our brain. Because of that neurons, because of the activation of those neurons, we are going to feel the sensing, and we are going to react immediately. For suppose if I'm having itching in my hand, what I did, itching in my hand, my neuron in the brain will be activated. It will give me an indication that there is something going wrong in your hand. So immediately I'll try to move from there, or I'll try to do some action. So humans are basically having that by birth. They are having all these imported facilities. Whereas coming to um softwares, what about the softwares, how they will behave as if the humans, they can't do it naturally, right? So we need to train the software, we need to train the machine, the computer system, in such a way that it is going to think as we humans think. It is going to act as we respond immediately, right? So what we'll be doing is we'll train the machine in such a way. For those training purposes, we need artificial intelligence software. Best examples of artificial intelligence will be the robotics. Robots will be using the expert systems, pattern recognition, artificial neural networks, and game playing, etc. All these comes under artificial intelligence software, right? And next, coming to the web applications. Web applications, as you all know, everyone will be using www dot. Any application that you run on your browser, on your Google, any browser, it can be a Firefox, it can be a Edge, it can be a Chrome, anything. Any application that you run on your browser will come under web applications. So softwares are all of all these categories which we saw here. So a small repetition. we are we are already late for this class today. That is why I am trying to move fastly. Maybe you understood or not. I am having a quick review, a quick 2 minutes review of the thing I have told now. First one is we saw a system software. System software, we gave you a best example is the operating Windows operating system. By using that software only, you will be able to interact with your hardware, or else you can't interact with your hardware. Next one is the application software. Application software is what we told is as per the area of the interest of the end user. If an end user is interested in some area, he'll load a software which will help him. It is not that it is not the basic thing to run the system, but as per the interest, you will be learning this application software. For example, we told a CAD, which will be loaded by most of the civil engineers, which will help them to do their work. Next is engineering and scientific software. All the softwares that help in engineering fields and all the software that can help in scientific fields, which include most number of mathematical issues. All these softwares comes under engineering and scientific software. Example is softwares used in astronomy, softwares used in volcanology, softwares used in molecular theory, biology, all these things come here. Next one is the embedded software, software by which you can interact with your hardware and hardware and the software. Best examples is in day-to-day life, the washing machines, the cars, the ovens or smart watches, what you are using here. All these comes under embedded software. And next is a product line software, softwares that are designed to a particular group of product. The product can be a group of cars, product can be a group of systems, it can be a group of watches, it can be a group of mobiles, all these softwares that run on a particular group. And next one we saw is web applications, all the applications that run on web in the sense your browser, all these comes under web softwares, web applications. And the last one is the artificial intelligence. Next examples are your robots, where the robots react or act by themselves as if the human react or act. These are the best examples for artificial intelligence. Uh, Students, hello. Sir,
Absolutely.
okay, is it clear? Are you able to understand or is it little fast?
No, ma'am, it is able to understand.
Okay, right. Why? Because we are lagging. Already it is 30 minutes class, and we because of late entry, I had 20 minutes. So that is why I'm trying to make it fast. So for today, all the people who have joined by 9 o'clock, please leave the class so that the rest of the people can enter.
Okay, ma'am.
Hello everyone. Hello everyone. Hope all of you are the students who have joined the second part. Is it so? Please any of you respond. All the students who have joined in the morning has left the room, right? Please, any of you respond.
Yes, ma'am.
So all of you are joined at 9:30, right? Because of a network issue, class was 5 minutes late today. Please consider it. And coming to our class quickly. Dear students, as we already told you, this problem will be just for 2 days. Within 2 days, we'll be having a premium account so that all the people can join at the same time. There is no partitions of dividing the class. 1 minute. So students, yesterday's class, this is what we saw yesterday. In yesterday's class, we had an quick review of objectives that of our course. We saw the outcomes, what you people will be learning by the end of the semester. We had a quick review of all these outcomes. And next we saw what is the necessary for learning the software engineering subject. Why can't we just develop a software without having any basic principles? What is the reason for particularly for learning this subject? That all the things we saw yesterday. And next we started our introduction part. In the introduction part, we need to start with software engineering definition, right? For that purpose, we started with what is a software. We told that software is having three components. First one is the instructions. All these instructions together perform the task. And next one is we are having the data structures. By using these data structures, you can manipulate your information, and manipulate your programs. And last one is documentation part, which helps us in performing the operations of using the programs, right? So generally what you people say is software is nothing but a group of programs. It is a informal definition. But the formal definition should be software should be a group of instructions performing a task, the group of data structures, and the documentation part. Together only you call it as a software. And next, coming to the engineering, we saw the basic definition, like engineering is nothing but using some specific principles, methods, and procedures for developing any product. That product can be either a software product or it can be any hardware product also. To develop any product, we need to follow some principles, methods. That is what the definition we saw for engineering. And combining both these two definitions, we finally came for the definition of software engineering. What we told is the software engineering is the application of systematic, disciplined, quantifiable approach for the development, operation, and maintenance of any software. So this is what we saw the definition yesterday. So what we are typing here is our main intention is to develop any software. Our main intention is to develop a software, to perform operations on that software, and finally to maintain that software. For doing this, what we need to follow is we need to follow some systematic, some structured way, some structured approach, some disciplined approach, some repeatable approach, and some quantifiable approach, some measurable approach. By using these approaches only, you can finally develop your end product correctly. This is what we saw the definition for software engineering. And yesterday's class, we started with the characteristics of software. Mainly, we tried to justify three characteristics of software, differentiating a software from a hardware. Among which the first one is we are saying that the software is engineered, it is not manufactured. The reason behind this is for hardware components, while you are developing any hardware component, you say that the component is manufactured. Whereas while developing any software component, we say that the product is developed, software is developed but not manufactured. In both the cases, while developing a product, first of all, you need to have a quality design. Then only your end product will be a good product. For preparing any hardware component also, basically you need to have a good design. For in the same way, for starting coding also, for developing any software component, software also, you need to have a good design. But the failure rate for developing any hardware component will be more when compared to failure rate for developing any software component. In the sense, if a failure occurs in a hardware, it takes us some time to rectify when compared to the software. And in the same case, the manpower or the human resources that are used to develop any hardware component will be more when compared to that of the software. Okay, right? So this is what we tried to justify yesterday. That is what we saw in the first characteristics, and the second characteristics what we told is software doesn't wear out as it is done in the case of hardware. If you see this, uh, this is what we saw, the second characteristics. What we are trying to tell here is the first graph is for hardware components. In the hardware components, you are having time in the x-axis and the failure rate in the y-axis. What we try to tell here is initially while developing a hardware component, the failure rate will be high. See here, the failure rate is high here. The failure rate is high. Initially, the failure rate is high by developing any hardware, and after certain time, what we do is we try to rectify all those failures and bring it to a normal stage. So the failures has decreased here, and once the failures has decreased and the product is released into the market, the product keeps on working steadily for a couple of years. For some period of time, it keeps on working steady normally. But after some years, as it is a hardware, uh, because of some environmental conditions or some any of the issues, it can be due to dust or it can be any environment temperature conditions or anything, the component keeps on deteriorating, it keeps on failing again. So again the failure rate increases here. That is what we showed in this curve. Right? If you consider a car, while you purchase a car, while the car is being manufactured in the industry, while manufacturing the car, initially they'll be having more failures. They'll try to rectify all the failures and bring it to the market. Once it is brought to the market, keeps on working for a couple of years, and after some couple of years, you'll be having some problems in maybe some battery or some brakes or some tires, anything that it might be. Because of some environment conditions, all those components keeps on failing, and again the failure rate increases for the car. This is what we try to show here. And the same thing when coming to the software. So initially while developing the software also the failure rate will be high. So the curve is high here. The failure rate is high here while developing the software. Why? Because we'll be undergoing many number of errors. We'll face many errors there while developing the software. We try to rectify all those errors. We try to rectify all those errors and try to bring it to a normal stage. We rectify all the bugs and bring it to the normal stage. So once the product is ready, the software is ready, when released into the market, the software keeps on working continuously in the same way, in an idealized way for a number of years. It does not tear out or it does not wear out as it is done in the case of hardware. Unless and until you make the changes, until and until we make changes in a software, right? So that is the curve we are showing here. Initially, the failure is high, and once released, the working of the software keeps on steadily. So this is what we showed here, and the curve above the second curve here. See the second curve. See the second curve. This is what this is again showing for the software only. So initially the failure rate is high, as we already told you. As time moves on, the failures will be rectified, and after some amount of time, see, I'm showing a dot here, a black color dot here. See this, what this dot indicates is if you want to make any change in a software. For suppose I have a Word document previously, Microsoft Word 2003 version. In that version, I'm having some basic features only. And the next stage, they released 2005, 2000, now you are in 2017 version or something like that. So what happened is when the 2003 version is released, they added some more advanced features and released the next version. Again, some features and released the next version, so on. So all those features are nothing but the changes they are going to make in the software. When you try to make any changes in the software, what generally happens is again the failure rate increases. We'll be facing some failures there. We'll be facing some errors there, and you'll try to rectify all those errors and try to bring it to a normal stage. So right, again when you try to make some other change, these are not the changes made by you, these are the changes made by the developers of the software. But suppose if you consider the Microsoft Word, the changes made by the Microsoft people, when the Microsoft people make some changes, for them the failures will be increased. Again they bring it to a normal stage and release into the market, again the failures increase. So the things go on in this way. This is the curve, this is the graph representing the failure rates of the software. So this is what we saw, difference between the hardware and difference between the software. Next, coming to the third characteristics, what we told is third characteristic is one minute. Sorry, the third characteristics, what we told is industry is moving towards component-based construction, and most of the software continues to be custom-built. Here, components are nothing but reusable components. As I already told you, for developing any software, we don't always start from the beginning there. What we do is, if you want to develop any software component, we try to make use of the maximum components that are already present, maximum modules that are already present. For suppose if you want to develop a project for supermarket application, there are a number of supermarket applications which have already been developed. So what you try to do is you take all those components from the previous application, you check all those components, you try to make use of the maximum code. Okay, right? You don't start from the beginning. You just make only necessary changes where you think it is necessary to do, right? So those are nothing but reusable components, nothing but modules in your language. In your C language, we call them as modules or nothing. You'll be writing by using functions, the modules, right? So if you want to use any module in your next project, you take that module, you study all that module, you try to check how far that module will be helpful for you. You'll try to make the maximum use of that module and just make only the necessary changes wherever it is necessary, right? So that is what we are saying here. What generally happens in software industry is we always make use of the maximum reusable components. So industry is moving towards component based construction, right? And more software continues to be custom built. Even though we are having most of the components, you need to make some changes there, you need to make some necessary modifications there, so you need to have some custom build. That is what we are saying here. So these are the three characteristics of software which we saw yesterday. And next one, coming to, so students, are you able to hear me? So number 95. Number 95. So what are the three characteristics we have told you? First characteristic is Babu 95. Babu. Hello? వినట్లేదు క్లాస్ జస్ట్ ఆన్ లో పెట్టారా? Number 95, please respond to me.
Ma'am.
Characteristics, what are the characteristics? What? Just tell me any one characteristics of software.
Software does not wear out, ma'am.
Right. Any other thing? Any other characteristic? Okay, right.
Not remember, ma'am.
నాట్ రిమెంబరింగ్ అంటే నువ్వు పక్కన టీవీ ఆన్ చేసుకొని క్లాస్ వింటే ఏం రిమెంబర్ చేస్తావు? Okay, right. Students, please try to write the key points at least. Anyway, I'll be sharing you the PPT and the notes. While listening to class, please try to note down the key points, at least a running notes type of thing. Okay, right. Now coming to the next topic is software applications. These are I can say these are the different types of softwares, different kinds applications of softwares. What are all the areas where we'll be using the softwares? In that, the first one is the system software, application, engineering, embedded, product line, web apps, and finally the artificial software. So these are the different areas where we'll be using the softwares, among which the first one is the system software. Systems of what's just a second. It's already 9:58. Next hour is
Yes, ma'am.
okay. So do one thing. All the students who have joined lately today, please join lately tomorrow also. I mean lately in the sense in the second half. Please try to join in the second half tomorrow. Okay, right. Just wait. I'll try to cover fastly within 2 minutes. First one is system software. These are the softwares that are designed to provide a platform for another software to run. See, right, example of the system software which you people will be seeing is the operating system. Once you purchase any laptop or desktop, you can't directly interact with your laptop or desktop without loading some basic softwares into it. So the basic software first you will be learning is loading is the operating system. Operating system is an example of a system software. What the system software is going to do is, if this system software, whatever Windows you are loading, this Windows is helping you, who is sitting in before the laptop, to interact with the laptop, right? Whenever you bring a laptop, it's just a hardware component. In order for you people to interact with that hardware component, you need to load some software. That software should help you, should act as an intermediate between you and the hardware component, whichever you brought. So, right, those kinds of softwares are called as system softwares, by which you are going to interact with some other software. Example for that is a Windows or Linux operating systems, all this. In your phones, you will be having Androids, all this. Android OS. By using that Android OS only, you are able to interact with, perform operations on your mobiles, right? And the second one is the application software. Application software is a program or a group of programs designed for end users. In the sense, some people, some students will be having one second. You people are late for dear students. One small announcement. You people have joined lately for me, right? One thing you do, you joined lately for DS class also. You join in the second half, so that I'll take some 5 minutes class now. I'll continue 5 minutes class now. Please cooperate with me for today. From tomorrow onwards, we'll try to end our class by within the time. So please stay with me for 5 minutes. You join in the second half of the DS class. See here. Right. We are saying the types of softwares, right? In that, the second one we are saying is application software. Example for application software will be any software that is the area of interest for the end user. Any standalone programs. For example, if you take a CAD software, this CAD software is loaded by most of the civil engineers. what this software helps is, this software helps them to design plans, to design some plans for building, right? This is only used for civil engineering people. This software will not be used by any of the rest of the engineering people, only used by civil engineering people. So they will wantedly load those softwares in their desktops or laptops, right? If you don't load this CAD software in this laptop, your laptop doesn't stop working or so. Why that people has loaded that software? Only because it is of their interest. Suppose you people are interested, some of your students will be interested in designing games. You load a software which will be helpful for you to design the game, for designing a new games. It's not that if you don't load that gaming software, your system stops working. It's not like that. Your system keeps on working even though you load that game software, or even though you don't load that game software also, your system keeps on working. The only purpose of loading that software is because of your interest. So that is what we are saying here. Application software is a program or a group of programs designed for end users. Only on based on the end user's interest, you will be learning some set of software. Those are called as application softwares. And next one is a product line software. These are designed to provide a specific capability for use by many different customers. Some group of softwares which are related to some product. For suppose a product can be a car. I'll be having some group of softwares which will be helpful in all those parts. All those group of cars can be able to use that software. For suppose if I'm having a group of mobile phones, in all those mobile phones, I can load a similar software. If I'm having a group of maybe some vehicles, in those vehicles, all those vehicles will be using those software. So any kind of such softwares will be called as a product line softwares, right? It can be, that product can be limited for a small group of people, or that product for software can be used for a large group of people. For suppose if you are having any remote sensing software, maybe any aeronautical software, anything like that. Generally, those softwares will be used by only some group of people. If it is a remote sensing software, all the general people might not be using that software, right? Only some group of technical people will be using that software. So limited people will be using that software, right? And on the other way, if you are using any word processing or any schooling software, for suppose most of the classes are done online now. Byju's is a famous app for most of the kids now. So most of the people will be using that software. So what we mean to see here is, the product line software might be used by a limited group of people, or the product line software might be used by a large group of people. Anything a group of people will be using will be coming under this product line software. Example for that is word processing, word software, spreadsheets, Excel sheets, computer graphics will be used by most of the people. Multimedia, entertainment, all the softwares related to entertainment will be used. Related to database management will be used by most of the people. Financial, personal application. So these are the software used by most of the people. In the same way, you have softwares used by limited people also. So all those softwares which comes under a group are called as product line softwares. And next, coming to embedded software, a software which works on both software and hardware is known as an embedded software. For suppose you are having your washing machines or ovens in your home, or digital watches. So nowadays, most of the people are having digital watches. So digital watch or a washing machine, basically it is a hardware component. But you people are able to interact with that hardware component by loading some software into it. I can set the time of my washing in my washing machine. I can set the temperature in the oven, micro oven. No, you can set the temperature by using some software. In digital watches, you can track your heartbeat, or you can pulse rate also in digital watches by using some softwares. So all these kinds of softwares comes under embedded software. So all the softwares that are embedded in the hardware, in the machines or ovens, all this comes under the embedded software. So what we are saying is, any software which works on both software and hardware are called as embedded software. And next, coming to engineering and scientific software, as the name specifies, the softwares that are used by limited group of people. The softwares that are used only by engineering people comes under engineering. Softwares that are used by scientific people comes under scientific softwares, right? So what we are saying here is engineering and scientific softwares have been designed by number of crunching algorithms. Here, crunching in the sense, all those algorithms of software will be having most number of mathematical calculations, mathematical issues involved with them. For example of all those softwares is some softwares used in astronomy. Astronomy in the sense studying about the galaxies, studying about the planets, objects, all these things. There are some softwares used in that area. Astronomy industries softwares. Similarly, there are some softwares used in volcanology detections, used as softwares. So these softwares are related to some engineering purpose or scientific purpose. So Alane, there are some softwares related to molecular biology, automated manufacturing, all these things. So these are the set of softwares related to scientific and engineering purposes softwares. And next we are having artificial intelligence software. Right? This is the current trending word or buzzword which all the computer science people will be are hearing nowadays. Everything we are saying is artificial intelligence. So what is this artificial intelligence softwares? These are nothing but the softwares which are going to mimic a human brain, which are going to act as a humans. Generally, we humans react to things naturally. Why? Because we are having the neurons in our brain. When anything, for suppose I'm having some fire or someone is coming close to me suddenly, what I do is I suddenly go back. Why? Because I have a sense, I have a neuron activated in my brain. It indicates me that, it tells me that there is someone coming near you, just go back or do something else. Why I have responded spontaneously? Why? Because I'm having some activation functions in my brain. The same thing, what we do is we make the software, we make the machine also. Machine in the sense you make your system also act accordingly. Not you don't always tell the system to do this and that. The system by itself, it learns by itself and do it accordingly as we do. Example for that will be a robots. So right, you train the robots to some extent, but you don't uh, say all the things. You don't do all the things. Train all the things. In the sense, for suppose you will be training the system to some extent. You make the system learn by itself by in the rest of the cases. For example, maybe small example I need to say is, for suppose I am giving you some three animal photos, maybe a cat, one dog, and some bird. I'll try to identify what is the cat image there. If I'm giving you only just three photos and asking you to identify a cat, you people will be doing it easily. Why? Because you're having only three photos in front of you. You'll be identifying it easily, and it takes very less time to identify. For suppose if I give you some thousands and thousands of images and ask you to identify all the cat images in those things, you will be able to do it, but it becomes more complex for our humans to do all the things manually, right? You can't sit in before the system and identify each image individually. It takes more time to do so. So in that case, what you will do is you'll train your system, you'll give training to your system, you'll say all the features of a cat to the system. You'll say the cat image features like cat eyes look like this, ears look like this, and these will be this hair look like this. All this you'll be training your system regarding all the features of the cat and make the system learn by itself. So finally, your system will be able to identify the cat image by giving your training. By taking your training, your system will be able to identify the cat image by itself from thousands and millions of images, right? In that way, it will be training the system. So this is all about artificial intelligence software, which we are seeing nowadays. And next one is web applications, web softwares. Any application that is going to run on a web in the sense www, anything you type on a browser, all this comes under web applications. Web pages retrieved by a browser are software that incorporates executable instructions. So web application can be any client server computer programs which the client runs on a web browser. Any client server program that is run on the browser. It can be either a Google Chrome, or it can be a Chrome, or it can be a Edge, Microsoft Edge, or it can be a Mozilla Firefox, anything. Anything that you runs on a browser comes under web application. Example for web application will be your webmail. So these are the different kinds of softwares which we'll be using in different areas. A quick review of all the software applications. First one is system software. Best example for system software is your Windows operating system. By using the system software only, you can interact with your computer. So we can say that these are the softwares used to make another softwares run. Okay, right? For interacting with the printer, you need to load all the printer driver softwares, right? If you load only the printer driver softwares only, then only you can interact with your printer. You can send copies to your printer. So what that system software is doing there is, it is a software which is helping us to interact with some other software. And next one is application software. As I already told you, application softwares will help us to do our specific purpose of interest things, like end user interest things. For example, I'm very much interested in painting. I'll load a software which helps me in designing new paintings. I'm very much interested in gaming. I'll load a software which will help me in designing gaming software, something like that. These softwares are only because of loaded only because of area of interest of end users. So all those comes under application software. Next one is engineering and scientific software. Softwares that are particularly used for engineering field and softwares that are used for scientific field. Engineering వాళ్ళకి పనికొచ్చే సాఫ్ట్వేర్, సివిల్ వాళ్ళకి CAD CAM పనికొచ్చే, కంప్యూటర్ సైన్స్ వాళ్ళకి పనికొచ్చే సాఫ్ట్వేర్స్ డిఫరెంట్ గా ఉంటాయి. And mechanical different, electrical different. Electrical people will be using MATLAB, all these kinds of things. So these are particularly related to engineering field, and similarly particularly related to scientific field. It can be another astrologic సంబంధించిన software, volcanologic సంబంధించిన software, industry automation కి సంబంధించిన software, molecular biology కి సంబంధించిన software, anything of scientific field. So all the softwares related to that particular fields comes under engineering or scientific. Next one is embedded software, by which you are going to interact with software and hardware, right? Examples are washing machine softwares, or car softwares, or oven softwares, or digital watcher softwares. All these softwares. What you are doing here is you are embedding embedding some software into your hardware, by which you can interact with that hardware, right? And next one is product line software. All the software related to some product line, group of product lines, right? Group of car software, so group of mobile watches software, so all these things. Next one is web applications. All the softwares that are running on the web. Client server programs, where the client interacts to the server by using a web browser. All this comes under web applications. And finally, the last one is artificial intelligence software, where the softwares behave as if the humans do. Example for that one is robots. Robots just behave as the humans. How they are going to behave? Why? Because we are giving training for them in such a way that they're able to understand all the things that are going around them by itself, right? So all these comes under different kinds of softwares. So students, do you have any doubts? So shall we leave the class? Or do you have any doubts? Number 7, do you have any doubts, or shall we leave the class?